Hello YouTubers and fellow hams, 3D printing enthusiasts. Way back in part 2 of my 3D printing for ham radio video, I introduced you to Tinkercad as a design program. Tinkercad is one of the simplest 3D design programs I've ever seen if you're getting into 3D printing. It's primitives based, meaning you can build complex objects, like my hand mic here, out of primitive shapes. Cubes, spheres, cylinders, and so on and so forth. Very much like Legos. And therefore very easy to use, very easy to grasp and learn and understand. And still pretty powerful. As you saw from my hand mic, you can make fairly complicated things with it. I wanted to move up the ladder into more complicated and more powerful design programs, and then make that the next part in the series. Well, that's what we're doing today. Today, we're going to look at a 3D design program called OnShape. And OnShape.com, or CAD.OnShape.com, is the website. Now, OnShape is a collaborative computer-aided design program. Modern, created to allow people to use it from any web browser, from tablets, cell phones, any device, really. It's very powerful. It's getting on par with programs like AutoCAD in that it can make extremely complicated parts. You can assemble parts together, have them interact with each other. You could, on the screen in your CAD program, model a clamp with a screw and a handle and actually set up rules so that you turn the screw and it behaves like it would in real life, so you can show assemblies. I mean, it's a very, very powerful program. Yet, it's still simple enough to be approachable and easy to understand. It is a move up from Tinkercad. I mean, it's a little more complicated. But I've been able to pick it up just using tutorial videos and playing around in it, and I've been able to make some fairly complicated things. For example, I'll show you a picture. Let me switch around here. And let's see, ham radio key parts, my straight key. I just finished this in OnShape, which is a straight key, obviously, designed for minimal hardware. I have a 3D printed spring here that's adjustable from a screw up top that'll compress this part of it and increase the tension. Snap fit hinge pin. The knob is also snap fit, and you can see the base has a nice design to it. We've got nice curved fillets here and curved edges. These are the things that are kind of hard to do in Tinkercad, and like this curve on the underside of the knob here, that's hard to do in Tinkercad. It would take a lot of steps and a lot of extra parts. And I even did a few fancy things, like there's little channels here that the wires travel through the base and through the arm to the contact points. Allowing the wires to be hidden when you're looking at the overall straight key. See, those wires are running right through here to this screw and to this screw down here. So it's nice and clean looking here on the surface. So you can do pretty complicated things in OnShape. But as I said, the program itself is a little more complicated to use. So today I'm going to show you OnShape, and we're just going to just touch on some of its capabilities. And to do so, I'm going to make a simple part. And what I'm going to make is this knob off of a J38 style telegraph key. Now, take a look at this knob, okay? Look at it in profile. You can see sort of the outline shape of it, almost a T shape except for that slope under there. That's important. You could look at this object from the top and you see a circle. You could look at it from the side and you see kind of this T shape to it, right? The reason that's important is that OnShape is based on sketches. Like most higher-end CAD programs, you create a two-dimensional flat sketch of a shape, and then you expand or extrude it into 3 dimensions, and then you apply operations to it to cut things into it, put holes through it, extend parts out of it, smooth it, twist it, loft it, do all kinds of things. So you always start with a two-dimensional sketch, like you would on paper, right? So let's go back into the program here. This is the main user interface to OnShape. By default, you have 3 planes defined here. You can see these. There's a front plane, there's a right plane or side plane, and then there's a top plane when you're looking down from the top. So the 3 dimensions are represented. And you start your design by drawing a sketch on one of those dimensions. Okay? So I'm going to draw an outline of that knob on the front plane. So I'll select the front plane, and I'll go up here to Sketch, up here in the upper left, and it creates a new sketch. Now you see this little window that popped up here. Every tool that you select will have a little window that will show you the options for that tool. So I've just created a new sketch on the front plane. It says that right here, front plane. And we're ready to start drawing on this plane. Now I can come over here. This little cube up here shows you your views, and I can click on front, and it'll switch to a front view looking right down at the front plane. I'll use the mouse wheel to zoom in a ways. I'll use the mouse button to position my display. And if I use the right mouse button, that would rotate. I don't want to rotate right now. I'm sitting on the front plane where I want to be. So I'm ready to start drawing the profile of my knob. Now, this knob is symmetrical, right? It's the same on this side as it is on this side. We've got perfect symmetry there. So a real neat shortcut for drawing this knob. I could draw the shape completely, the T, except that all I could do with that is extrude it out in 3 dimensions, and I would have square faces, right? It'd be like a block knob, like a Minecraft knob, instead of this nice round shape. Well, it's a round shape. So what I'm going to do is I'm going to draw half of the profile only. And then I'm going to take that half and I'm going to rotate it around the center to make the solid shape. Huh? So I'm going to draw the profile of my knob. And we're going to do that with the line tool up here in the upper left. Line. I'll select a line, and I'm going to start from this center just because that makes it easier to line things up. And I don't know if you can see it happening, but this center dot here is lighting up when I cross the center line, and you're seeing a little vertical line up here next to my pointer. That's telling me that I am on the center of that line. OnShape knows when you want to do things like in the center of a shape or whatever, and it'll highlight things, light things up, and indicate and lock to or snap to the center of things. That's very, very handy. For example, we'll do something like a rectangle here or a square. If I wanted to draw a line down the center of that square with the line tool, I could guess at it, but as I move the pointer right to the center, a little box appears around it and a little constraint dot icon, that little icon there that has a line with a dot in the middle, that's indicating that I am on the center of that line. OnShape knows that I probably want to work from the center of that point and automatically highlighted it to tell me that I was on the center of that object. So that's a very, very handy thing. Okay, let me get rid of this entity here. All right, so for our knob, I'm going to draw half of the profile of the knob, and it's a rough shape. It's about like so, like so, like so, like that, and back to here. Okay, so that is the profile. Now I need to connect it. I need to close it up. So I'm going to draw one more line vertically up to this dot. Boom. Okay. Now we've drawn roughly the outline of our knob. Now I'm going to refine that a little bit. We're going to add some dimensions to it. Okay. Now I know that this knob is 29 millimeters across the top. Okay. So I want this line here to be half of that. So I'm going to come up here, and there's tools across the top. Okay. And the tool I'm interested in is this one, which is these two little arrows pointing between lines. And you can see when you hover over things, it tells you what they are. And this is the dimension tool. And if I wait, it gives me a description of what that tool does and how to use it. 1, select the entity to dimension, or entities to dimension between, and then specify the value. And use enter to apply the value. So I'll select the tool. I'll select this top line. And there's my dimension. And then I can type in what I want it to be. And what did I say? Okay, 29 is the total. So half of that is 14.5, right? Now I've got to zoom out. Oh, you know what? That's working in inches. I want to work in millimeters. OnShape is an American company, so they default to inches. Which annoys me. I wish I could just set my default to be millimeters. All right, workspace units. Up under, this is the menu up here to 3 lines. Workspace units and default units in millimeters. Okay. Now, if I select that line and oh, got to go back into my sketch. I exited out of my sketch. While we're here, let's talk about this. Over here on the left is your features list. It shows all of the entities in your drawing. So my sketch shows up here as sketch 1. I didn't name it yet. If I double click that, I go back into sketch mode. It shows here in this little box that I'm editing my sketch. And here's my sketch with its dimension, 368.3 millimeters. No, we want that to be 14.5 millimeters. Boom, that's more reasonable. Let's zoom back in. Put that dimension down here closer so we can see it. Okay, now, what's the next dimension on our knob? Well, how thick is it at the top here? So I get my calipers out, and I'm going to measure that at the edge, and it is 2.5 millimeters thick. So I'll take the dimension tool, I'll pick this line, and we'll set it to be 2.5 millimeters. Okay, now the tricky part. We've got a slope that slopes down about halfway down, and the bottom of the knob from the bottom of that slope is 8 millimeters. So I guess the easy thing to do would be to dimension this line here at 8. And that slope adjusted itself. And now the bottom of the knob, I've already measured it, is a total of 13 millimeters. So I want to dimension this line at half of that, which would be, 6.5. And there is the dimensions of our knob. Now, in CAD, you're supposed to fully constrain sketches, which means you're supposed to lock down all the dimensions so that it can't be manipulated any further. Lines that are already locked in have turned black. Like this line here, I can't change the length of this line without affecting some other aspect of the sketch that I've already defined. So it is locked at 8 millimeters, and this is locked at 2.5. This can be changed still. I could grab this dot and I could pull this in. No, I shouldn't be able to, should I? Because that's locked in dimension there. Maybe I can move it up or down or something. That's why it's blue. Yeah, that's probably it. I haven't locked in this dimension here, this overall height, which we could do. So that would be 8 plus whatever this is, plus 2.5. The measurement tool. If I select, let me turn off dimensions. If I select 2 entities in my sketch, okay, like this line and this line, down here under my video, let me move myself out of the way. Can I move myself out of the way? There. Right down here, there is a little bit of text that says parallel distance 15.816 millimeters. That's telling me the distance between these two lines that I selected. So that's an automatic measurement tool. It's always there. 15.816. So if I come back into my drawing here, dimension, this line, 15.8133, okay, that's fine. 15.816, there, okay. Now that's locked in. All right, let me put my video back. All right, so now our lines in our sketch have all turned black. It's fully constrained, nothing can be changed anymore. That's what we wanted to see, so I'm done with this sketch. I've sketched the profile half my knob. I'll go up here to the checkbox and check the green checkbox to tell it, okay, I'm done with that. Now, I'm going to take this sketch, this two-dimensional object, and I'm going to come up here, and at the top here, there is a tool called Revolve. And the description says it creates, adds to, or subtracts from parts by revolving a sketch, meaning rotating it around. I'm going to choose that. It's already chosen sketch 1 as the sketch that I want to revolve because I had that selected over here. Here it wants to know revolve axis. What am I going to revolve it around? Well, I'm going to come over here and choose this line. And then how far to revolve it? Full is full 360 degrees. Hey, that's what we want, right? So that is our revolve. And if I hit the checkbox, you can see we now have the basic shape of the knob. Isn't that cool? What else do we need to do? We need to, before we clean it up, we need to put a hole in the bottom of it to be able to screw something into it. This knob here has a threaded insert already in it, right there. But I don't want to get into creating a thread or whatever. I'm just going to put a hole in the bottom of this knob that I could then put a screw into. So that brings me around to showing you another feature in here. To create that hole, I'm going to want to put it on this surface, right, on the bottom of the knob. So I'll select that surface to highlight it, and I'll come up here to the upper left and select Sketch. What I'm going to do is create another sketch on that surface of the knob. Okay, and it shows here sketch plane face of Revolve 1, which is this face. Now I can go up here and switch to the bottom view to flatten that out to look at it. I can right click on the screen, and view normal to will do the same sort of thing. No, it didn't. Should have. I'm going to select the face and do it there. View normal to. Yeah, there we go. All right, now I'm looking straight at the bottom of the knob. Okay, and I'm creating a sketch on here, right? I'm going to come up here and use the circle, center point circle tool. And when I choose that, I come down here to where my sketch is. Now, as I move my pointer around and get across that center point, it's going to have a little box up here around it. And that's telling me if I click here, I'm going to be locking the center of that circle to that center point, which is exactly what I want because it's central to this face. So I'll click and I'll drag out to create a circle. And there we go. Now I just need to assign it a dimension. We turn off the circle tool, double click on that dimension. And I know from experience that if I want to thread a fairly common screw type, like you use to mount hard drives, here in the US they're 6/32 or 6/32 is the thread pitch and length. I want to make a 3.4 millimeter hole. Now, I really want a 3 millimeter hole, but when you're 3D printing, the bead that your 3D printer is laying down is 0.4 millimeters wide. So if I want to make a 3 millimeter hole, I have to account for that half of that bead that's going to overlap the inside of that hole on either side, right? Which would be 0.2 and 0.2, so 0.4. By making that hole 0.4 millimeters bigger, I'm accounting for that little bit of overlap caused by the bead of material my 3D printer is laying down, and I'll end up with a 3 millimeter hole. So I'll set that at 3.4. I've created my sketch on this surface. It's all black, meaning it's fully constrained. It's locked to the center. It has a dimension. That's what we want to see. So I'll come up here and check the green box on sketch 2. In fact, I'll name this one too, just to keep it straight. Hole. And check the green box. And now you can see over here in my list, hole has appeared. And if I choose that and go up here and hit the extrude tool, what I'm going to do, now see by default, it's adding material, so it's extruding outwards. Nope, I want it to be a hole, so I'm going to click remove. And OnShape is going to be smart enough to figure out I probably want to do a hole into the object, and it's going to, arbitrarily choose some depth here. But I can choose that right here. I could make the hole go through all by selecting it on this list, and it would go all the way to the top of the knob. Up to another part, up to another face. If you were working with a multi-dimensional part, you had all kinds of different faces, and you were making a hole just through part of it, you might choose up the next face to just to get through that little part. Blind simply means I'm making a hole, and I'm going to choose how deep I want it to be, and I'll make it 7 millimeters deep. Merge with all is important because that's going to merge this part, this extrusion into this part. So we always check that. I'm still learning OnShape myself. A lot of details I'm missing, but there we go. Now you can see our knob has a 7 millimeter hole right in the bottom that we can screw a screw into. Okay, time to clean it up. Now this is what I really like about OnShape, where it excels over Tinkercad for making clean and pretty parts. Up here in the tools, you have fillet and chamfer. Now a chamfer is simply an angular cut across the corner. A fillet is a nice curved rounding of an edge. I'm going to choose the fillet tool. And it brings up a box, right? The first highlighted thing is entities to fillet, all right? So I want to fillet this top circle of the knob and this one, and it defaulted to 5 millimeters radius, which is just too big. I'll make that 2. Let's see how it looks. Oh, it doesn't like this one. Let me uncheck that one. We'll just look at the top. Okay, there's our top at 2 millimeters, and that's nicely rounded. I'm going to make a second fillet for this one and lower that value quite a bit. So I'll choose fillet again. We'll choose that ring and go with a very low value. Okay, it took 1. Let's see how that looks. Yeah, that's a nice smooth transition. Where did I go a little higher? 1.5. There we go. I like that. See how nicely rounded that looks? Look at that. And now I want to fillet this ring here to smooth that transition. So I'll hit fillet. I'll pick this ring. And as you can see, OnShape automatically figured out that this is an inward facing cut, so it went to an inward facing round. And there's an arrow here, and I can just drag this out to get the visual appearance I want. Like, that looks really nice. Let's do it about there. Boom. Look at that. And there is our knob. The only thing left to do would be to print it and then mount it on the key. So you can see OnShape lets you create much nicer looking parts. And you can get really complicated with it. I've created a straight key. I've created, here, let me close this document and I'll go and show you one of the other things I created. Here's my Morse key that I just finished up. And it consists of several parts. And you can see I've got the base, I've got the arm up there. This is actually a spring that sits on the bottom of the key that is 3D printed right along with the key. I made this snap fit hinge pin that goes through there and snaps in place. You can't really see them through the models, but on the back you see this little hole here and this little hole here. those are channels that go all the way through into the pockets where the screws are. So you can run a wire right through the body of the key, right up here to make contact with the screw, and it makes for a cleaner looking appearance. And of course I've used fillets, here around the base of the support to give them a little more strength and a little nicer look. I filleted this bottom edge of the key base here. I used fillets to round the edges of the arm here and there underneath and on the back. So OnShape let me create some very nice, clean looking features with this thing. Oh, come on, straighten up, there we go. And you can get even more complex than that. You can get very complex with this thing. You can create complex geared assemblies and things. It has tons and tons and tons of power. I'm only scratching the surface here. But it's free. It runs on all platforms, all devices. You can collaborate with it. You can share a design with somebody else that's on OnShape and work together on a part. It's really quite powerful. Yet it's easy enough to start to figure out that you can get into it and move forward. As I showed you here, you start with simple sketches, simple tools to extrude them or whatever. Oh, and when you're ready to export your part out for printing, let's go back to the knob we just created. All right, so here's our knob that we just made. If I wanted to export this for printing on the 3D printer, down here in the lower left is our parts list. And I click on that to highlight it. You can see it light up. If I right click on that part, one of the options here is export. I'll select export and we get a window where we can name it. We can choose the file type, units of measure. Resolution is how many facets it has. If I put this in low resolution, where there's curved surfaces, you might actually see that they're made up of flat sides, little bitty flat sides. And then, of course, high resolution has even more curves and more smoothness. I found that medium is fine. If you had a really small part with lots of fine detail and curves, like a model of a face, you might want to go to resolution fine to get those extra details. But here you just type in your part name, knob for video, and it has exported the file. I'm ready to slice it and send it to my printer. So there you go. That is OnShape. Check it out. If you're getting into 3D printing and you're really beginning to enjoy it, this is the next level in design. There are standalone programs for Windows like Fusion 360 and others that I'm not going to cover because I'm concentrating on tools that can be used by anybody on any platform, Linux, Mac, Windows, or whatever. And this is definitely one of those tools. Runs in a web browser, runs on a tablet, it'll even run on your phone. Although, boy, you'd have to be dedicated to do that. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.